Hello? Hello, hello? Advent of code, 3 minutes. Definitely I'm on time. Totally. I need my chat. About chat. That over here. Mm-hmm. Okay. Add. All right, I guess we do the ad at the start. Hello.
Osteopathic manipulative medicine. What a wild name.
Okay, I'm here.
Unlike chiropractor, they teach your body to go back to where it belongs. My wife uses her migraines. Oh, okay. Interesting. Yeah, dude. Yeah. Yesterday, I fired it in there on some acupuncture. Like,
This
I'm
button.
going to a licensed massage therapist. Like, I'm willing to try anything.
How was my day? This is the start of my day.
Oh, hey, Bad Cop's here. Let's go ahead and get that stream started.
Uh-oh. Where's my virtual camera? Let's refresh that.
I'm in my 40s now. Probably will never work a job with over a 4-day work week or a 6-hour day again. Dude, I feel that. Like, yeah, of course I got the standard 5 days a week, but I get that. Like, you start to become very defensive of your own time, and it's good. You should be, because no one else will be. No one else will be, but you have to learn that lesson. Yo, what up, gamer?
Yo,
what up, gamer?
How's it going?
I knew you'd say it. Got there first.
I'm always just so on time. I'm just so ready
less than a minute.
Ready to go, you know, plenty of time. We could discuss like I don't know, like your favorite stocks or maybe some sports teams. But instead we have 40 seconds, so like just get it all out.
All right. Okay, here's my financial advice. Official 100% is financial advice.
Wait, I think you can't say that. You can't say that.
No, this is fake. This is not financial advice. I am not a CPA. Do not think that I am giving therapy or financial advice on stream. My favorite stock is VOO. If you want to invest in stocks,
oh, that's not a stock. Boo. That's an ETF. Boo.
Yep, get a nice ETF and don't try and win the system. That's my advice.
Yeah, that's good advice.
Yeah,
but it's not advice, so it's bad advice.
It's not. Yeah,
it's not advice at all. Yeah.
Oh my god. Oh my god. We have 1 second. Oh my god. Okay. Good luck.
Good luck. All right. Day 10, we're in the factory. Just across the hall, you find a large factory. Fortunately, the elves here have plenty of time to decorate. Unfortunately, it's because the factory machines are all offline, and none of the elves can figure out the initialization procedure. The elves do have the manual for the machines, but the section detailing the initialization procedure was eaten by a Shiba Inu. All that remains of the manual are some indicator light diagrams, button wiring schematics, and joltage requirements for each machine. For example, whatever the fuck that is. The manual describes 1 machine per line. Each line contains a single indicator light diagram in square brackets, 1 or more button wiring schematics in parentheses, and joltage requirements in curly braces. To start a machine, its indicator lights must match those shown in the diagram, where period means off and hashtag means on. The machine has the number of indicator lights shown, but its indicator lights are all initially off. Okay. So an indicator light diagram like that, off, on, off, means that the machine has 4 indicator lights, which are initially off, and the goal is to simultaneously configure the first light to be off, the second light to be on. Yes. Okay. You can toggle the state of indicator lights by pushing any of the listed buttons. Oh my god. Each button lists which indicator light it toggles, where 0 means the first light, 1 means the second light, and so on. When you push a button, each listed indicator light either turns on if it was off or turns off if it was on. You have to push each button an integer number of times. There's no such thing as 0.5 presses. nor can you push a button a negative amount of times. I'm scared. So button wiring schematic like 034 means that each time you press that button, the first, fourth, and fifth indicator light would all toggle between on and off. Okay. Okay. Because none of the machines are running, the voltage requirements are irrelevant and could be safely ignored. That's for later. You can push each button as many times as you like. However, to save on time, you'll need to determine the fewest total presses required to correctly configure all indicator lights for all machines in your list. There are a few ways to correctly configure the first machine. Good. I love when there's multiple ways. You can press the first 3 buttons once each, a total of 3 button presses. You could press 1, 3 once, 2, 3 once, and 0, 1 once, a total of 4 button presses. You could press all of the buttons except 1, 3 once each, a total of 5 button presses. Why is Dave so blurry on my stream? Let me refresh that. Oh, my camera's just like that. Interesting. The fewest button presses required is 2. One way to do this is pressing the last 2 buttons once each. I have no idea how to do this. Let's just be clear. This is not something I know how to do. What the fuck is this? I guess it depends on how many buttons there are. That's it for you? You're done? You finished it? But yeah, I assume it would depend on how many buttons there are. What's the fewest button presses required? Oh gosh. All right. I have some ideas of how to represent the state and implement the switching logic. Finding the minimal amount of presses is unknown. Yeah. I do too, but it depends massively on how many buttons there are. So let me grab the sample. This will be your last destination. Let me look at my input. All right, what are we working with here? So we got 1, 2, 3, 4, 5, 6, 7 buttons on this one. Let's count and triple click the sample to select all. Yeah, I mean that's true for any like paragraph. Okay, let's do this. Wrong thing. Let's take our how do I want to do this? You gotta put a space there. No? How doesn't that work? Do they not have this? What the hell? And TR. Complement. All right. Stood it for my side. Get rid of the new lines. Oh, is that why it wasn't working? Hold on. Echo. There we go. So, oh, but that's not per line. Okay. How do I get just the length of the line? Any idea how to approach this? I'm trying to count how many buttons are on each line. Let's just make a little function. Line length. While the length of the line. Okay. I don't like that I did this. And then let's do sort n. All right. Is this right, by the way? Sample 1. This one has 4 buttons. Is that right? 1, 2, 3. No. Why does it think there's 4 buttons? Hello? There's more. The heck? Oh. There's 6? Yeah, there's 6. But my line length thing is saying 4. Oh, it's because I'm sorting. I'm stupid. All right, I'm still waking up. 654. Yeah. All right. Now let's change a file to be input.txt for the moment. Okay. So the worst case scenario we have is 13 buttons.
Yo, okay. Do you have any idea how to do this?
I know that the worst case scenario is we got a machine with 13 buttons. That's what I figured out so far.
The worst case scenario. Wait, is that in your real input, you mean?
Yeah, in the real input, mine, there's a few 13s.
Oh, God. Okay, I didn't even look at that. I'm just looking at the example and trying to figure out what I would even do.
Yeah.
Oh,
yeah.
Boy. Okay.
13 is a lot.
Yeah, that's a ton. Oh, my God.
Because I don't know what 13 factorial is. Can BC do factorial? No.
I actually don't know.
13 factorial. It's like 6 billion.
It's not bad.
Yeah, it's pretty small.
Yeah, exactly. Okay, cool. I feel better now because I'm staring at this. I'm like, I don't even know what to do.
Well, so have you tried pushing the buttons?
That's what I was thinking. I was just gonna go in a loop and just keep pushing random buttons until I get that. I'm thinking, and then if we hit 500, then that's probably too many.
Well, if you're gonna do random buttons, make sure you keep track of which ones you press. That way, if you get the right answer, you like know how you got there.
Ooh, that's smart. I didn't think about that part.
Yeah, because otherwise you're gonna be like, oh no, I
Oh
got
my
the
god.
answer, but I don't know how.
Incredible. Thank you. All right, I'm gonna lock in. Good luck.
Good luck. All right, I was lying. I know how to do it. It's easy. I'm just kidding. I don't know how to do it. 13 is a bigger number than I thought it was gonna be. 13 is a way bigger number than I thought it was gonna be. Holy shit, 13 on part 1? Eric, excuse you. So okay, maybe we just need like a little algorithm here, you know? I think we need an algorithm if we're in 13 land. Yeah, 13 is too many. Like I can't even solve that manually. That's too many buttons. All right, let's do the thing that Dave is trying, which is stare at the input and see if we can ideate some big algorithm. 13. No, that's 10. But that's pretty close. Okay. So you see how like we want the lights to be on, but then the lights they start off. So that's one thing. That's one thing I would say is probably you have to consider. Well, this example is interesting because we've got some. This is like a baby puzzle, because you have some buttons that just do one light, and like, oh man, the answer here is actually just. Oh no, wait. Okay, it's a little bit harder than that, but I think maybe you split it. Yeah, because there's not necessarily gonna be a way to independently control each light. There's not necessarily like some combination that does that. Holy. Okay, well here, this is interesting. This button is just these two buttons combined. But that still could be useful if you're going for shortest. Give me a few minutes to think, but then you can jump in, yeah. Cause I don't think I know this. My initial thought was to just like try all the states. Well, does that still work? Because what is 13 factorial? What am I representing with 13 factorial? That might be the wrong math. Because you have your first move, you have 13 options. Then your second, so it really depends on what You have 13 options every move. It really just depends how deep it goes. Which we don't know. We know from the example it goes to 6. So like, what's 13 to the 6? That's probably 5 million. So if it only requires like 6 button presses, we can get there by trying. But you would never press the same button. Hold on. Wait, this is easy. This is so easy. Okay. Don't tell Dave. Don't tell Dave. This is actually easy. Do you want to know why? No, do you want to know why it's easy? All right. This is an XOR puzzle. So look at this. Look at this. If I press this button, what happens? The third light turns on. If I press this button again, what happens? The third light turns off. This is a no-op. You will never press the same button twice. Each button can only be pressed once. So you just have to figure out which combination of the 13 buttons. It's still not easy, but there's no depth. You just have to figure out which combination. Now, what is Pascal's triangle if you sum the row? What is sum of row of Pascal's triangle? It's 2 to the thing, right? So the row 0, if we're on row 13, what's 2 to the 13? 8,192. That's easy. That's the most number of things we gotta try. All right, let's do this. This is nice. This is nice. I like this one because I was staring at it like, what? This is insane. I have a feeling part 2 is gonna be insane, but this is not so bad. So we need to harvest how many lights we have. That's the first thing we need to do. Another thing is to implement it in Bash. No, this isn't too bad. Let's get this out of here. I don't need this. We want count lights. Yes. While read lights, other stuff, echo length of the lights, and then the other stuff. Oh wait, we need the lights too. No, hold on, not input. All right. So it's saying 6, but we need to subtract 2 for the thingies. Should we just get rid of that part? Yeah, let's just chop it off here. Lights equals lights replace this or this with nothing. Cool. Four lights, that's the state that they need to be in. 5 lights, that's the state they need to be in. Yeah, okay. We could even chop off the ending. So we do oh gosh. Is this? Yeah, there it goes. Maybe we could put a space there too. All right, it's gone. Is Dave frozen IRL? He might be. I don't know if you saw that. No, I saw him blink. He's working fine. His blink overlay. Should I what do we do here? We just do we do combinatorics? What's the easiest way to do? Oh, I hate doing this is my weakness. I always forget how to do it. Well, so we're gonna read What if we did this? Gonna lurk for Tarkov, have fun. Let's call this C and this desired. And then let's read a line. We can read dash A, right? Read dash A buttons. Echo buttons. Cool. We got our buttons separated out. And we need to go through for I in, that's not how you write this language. For I equals 0, I less than buttons echo button I. Well, that didn't work. Buttons. All right. Oh, I should have used var dump. That's okay. But the thing is, we don't want just this. This is where we do our fucked up combinatorics. Is recursion the right way to do this? You like... Yeah, you do like a loop in a recursive function over all the buttons. But how do you avoid duplicates? So I don't want duplicates. I guess each one just starts at a progressively higher index. All right. Can we break here? Do 1. Do you need to avoid duplicates? I want combinations. I want to generate the combinations of buttons. I know one way to do this, and I know how I would do it in another language, but I have a feeling it's going to be pretty slow in Bash. The way I like to do it for combinations is you take what? You take how many items you have. So say you have 13 items. You take this number, you loop from 0 to 8192, and then, or sorry, 8191, and then you look at the bits, and the bits tell you whether or not the thing is in the set. But that's going to be really slow in this. That was fun. Yeah, it's a good one. When I first opened it, I was like, what the hell is this? And then I was like, oh, I know exactly what this is. Now I just have to do the hard part, which is writing it. But I think Dave might still be, well, I don't know. He may have figured it out by now. So I want to make a function. Fuck, how do you do this? How do I do combinations in Bash? Maybe echo dash n. Can echo dash n help us here? If this takes, a local, so start equals 1. Count equals 2. Amount equals 3. Okay. All my permutation puzzle solving led to this moment. Like, the thing that I'm struggling with is just I don't know how to do it in this language. I don't know how to generate the combinations in a sane way. So I'm like, I know what I want to do. Let's do a loop here. Can we get a local I equals 0? No. Okay. Start at start. Less than count. Increment I. We know this much. You didn't generate them. Oh, do you just loop over them? I don't want to know. Let me cook. Wait, amount? No. Buttons I. Echo. Oh, I'm not calling this. Okay. Combinations 0 C I. All right. Is that what I wanted to do? Are there only 4 on the first line? No, there's 6. What the heck? Where did my buttons go? Oh, that's the count of the lights. Okay. Hold on. We don't care about that. Buttons. There we go. Okay. We're doing recursion. We're gonna recurse. It's gonna be fine. So that does that. Wait, shouldn't no, it should echo here. And then let's put a debug echo here. Okay, so these are the groups. So this is it generating all of the options that are length 1. Then we need to generate all the options that are length 2. So length 2 is just combinations. Start +1. What's the next arg? Count. Count stays the same. Amount -1. Um, how did it go? Equals this. If how did it go? Equals 1, then break. No, we don't need this. We don't need this part. Because we can just be smarter about our loop. Our loop goes from, for I equals start, we don't go to count. We go to count minus, oh shit. Yeah, minus amount. Maybe less than or equal to. Hold on. Take out the recursion step for a second. 1, 2, 3, 4, 5, 6. No, that's not right. Why are there 2 there? Shouldn't be 2. Oh. Oh, okay. Not less than or equal to. This should start. Wait. Yes, less than or equal to? This should start at 1, though. There we go. That looks right. It gets smaller and smaller. And then the recursion part. We need some base cases. If amount is 0, then what? We just return. Is that the only base case? Perhaps. No. This don't look right. Oh god, there's duplicates. Oh no. Okay, it started out strong, and then it fell apart. We just did. Wait, is this even? God, this is so confusing to do in Bash. Like, it looks like it's working. It's just printing out extra stuff, maybe? It printed out 4 of them. What is 6 choose 2? Should be 15. Hmm. Hmm. That didn't help. Uh, now, now what's it doing? No, it should be whoever's the 0 that does the echo, right? Shouldn't be this. That still doesn't look right. Okay, so what's it doing? This runs and then it calls this with 1. Let's just get a little stack trace here. Okay. So here we're at 0, 6, 2. And then 1, 6, 1. And then 2, 6, 0. Right, 2, 6, 0 again. But why didn't we print out here? Hold on. Put this down here. Make this one depth. Oh, wait a minute. It's not start plus 1, it's like I plus 1, right? Does that help? No. uh why not? Like the way it works in my head, it should work. I wonder if it's just hitting this case too much. Yeah. Yeah, I think it's just breaking too many lines up. Oh, I see why. I see why. This yeah, we need to like pass a we need to accumulate onto one string and pass that down. Instead of doing echo. Echo's never gonna work. Because it's gotta be repeated. Ac equals let's make it nice. If there's nothing in the accumulator, then otherwise do this one. Okay, that's a lot of sad faces. I'm not on part 2 yet. Don't worry. Now it's broken. Why is it broken? Why is it broken? String. That still don't look right. No, oh, wait a minute. Okay. I love programming. Isn't it so fun? Look at all these. Look at all these options we have. Look at that. Cool. Let's get rid of the parens because they're not doing anything. Don't need those. So these are our buttons in the order that I would like to press them. So we're looking for the shortest. So we're actually searching through this list in order, which is perfect. So let's say while read attempt echo the attempt. And then we'll just put this into here. This is fun. Are you making progress?
Yes, but very slowly.
Same,
I think
same,
I'm
okay.
onto something, but this kind of sucks.
I got a message in my chat that says part 1 was hard, but what the fuck is part 2? Which is, you know,
Oh god.
but Meep was done at 30 minutes, I think.
Okay, isn't that a long time for them?
Yeah, yeah.
Oh no.
I'm at the point where I know what I want to do, and like I think it would be fairly straightforward and dare I say a different programming language. Um, but
You're sticking it out. You're
I'm
sticking with
battling
it.
against the the
Okay.
language that we have.
Okay. Listen, we have the best language. I don't know what you're talking about.
Yeah, it's true. I mean, I got it to do the thing. Now I just need to do a other thing, and
Yeah.
it's going great.
Yeah. I don't know. This one's tough.
I sure wish we had a way to index into strings, you know, since everything's like a string.
Yeah, but I mean, you have to use that stupid substring notation to do that.
Yeah, like why can't I
Yeah.
just like say my variable square brackets 1 equals
I agree.
letter?
I agree. I wish I could just use the array
Like
notation. The
like
amount of
C
times I
can do
mix it up.
this, and we're
Yeah.
just using C strings underneath anyways. Like
Yep.
we should add this. It should be our contribution to Bash.
I like this idea.
The problem, I think the
legitimately
problem
do.
with it is it would need I think it would need different syntax, because if you use the square brackets, I think Bash like automatically assumes that you want that variable to like be an array now.
Oh yeah. I mean, Bash has types. It knows it's a string, kind of.
It doesn't though, because like you don't have to declare arrays. You just start using them and they become arrays.
Oh, you're right. You're right. Oh, that's true. That
They
sucks.
they designed us into a corner. I mean, we could make a
God,
fork.
that's true, though.
We could have Bash. I
You
don't
wanna make
know.
a fork of it? Oh my
Bash
god.
Community Edition. Change the rules. But okay, I'm gonna keep going. I just
Yeah, same.
seeing if you were stuck.
No, I got something. We'll see if I can get it to work. Okay, go
How many lines of code do you have?
Let's see actually. Word count dash L. 81.
Oh my god, wait, you're beating me. I only have 51.
Oh my god. Well, I'm very verbose. I have comments in my code.
I deleted mine.
That
I had some.
hurts me. Oh my god. That hurts.
All right, good luck.
Alright, good luck.
I think we're gonna win. I think we're gonna win. We just need to make the thingy that does the thingy now. You know what I mean? Because like we know our desired. Like we know that we want this at the end. Actually, I bet there's a nice way we can do this with an array. So can we say initial equals this for j equals 0, j less than c, initial plus equals a dot. Okay, so we've got an array with four dots in it. So let's have state equal this, which I think is how you do that. And then you can do state. Cool. We need to loop over all of the numbers in the attempt, or all of the buttons in the attempt. Gosh. There's a lot going on here. So maybe we should read attempt as an array. Cool. I guess let's get another variable in here. For k equals 0, k less than length of attempt array, k plus plus, do done, echo attempt k. So these are the individual buttons. Well, hold on. No, let's be more clever. Because an attempt is not a set of button presses. Well, shit, it is, because that's what our answer is. So we do need to know how many buttons it was. Dang. Okay. That's fine. What's one more loop? What comes after KL? Let's read our buttons. Let's call it butts, because we already used buttons. Butts equals, no, we're gonna read a butts. IFS equals that. Read a butts from this guy. All right. And now exactly what you're thinking. Oh. We just switch to L's, change this to butts. And now we can echo but L. Ah. That has not worked so well. Yes, we've lost our butts. Is it because I typed button instead of butts? All right, the butts are back. Look at all these butts. So for each one of those, we just need to do flip the bit. So but equals this for not for. We're done with for loops. State but current equals state but case cur in dot hashtag ESAC state but equals dot state but equals hashtag. Ooh, you see that? Look at that. Look at all these. That's pretty good. I bet one of these looks like this one. Yeah, right here. All right. So let's do final equals state. Final equals final with the spaces removed. And then put final in here. Right. We just compare final to desired. And if it is, we win. Final equals desired. Then go yay. What's the thing that we care about? It's the length of attempts. Length of the attempt. So for the first one, can we do it in 2? One way to do this is by pressing the last 2 buttons twice. Attempt. I don't know what the last 2 buttons are, to be honest. I'm gonna trust that that's right because it's the right number. Oh boy, how many breaks do we have to go out of? Okay, we want to break the while loop and the for loop. So that's going to be a break 2 situation. And then we get rid of this break. And we're on 232 is 7. So you add those together. It's supposed to be 7. Come on. Come on. 396. Pretty easy. Pretty easy. And there it is. And that's how it's done.
You get it? Nice.
I got
I
it.
feel like I'm so close. I'm fighting with Bash's syntax right now. That's how bad it is.
Yep.
Oh, it sucks.
So you know the do you know the strategy here? Do you have a strategy?
To what?
What's your strategy?
Well, hold on. Let me get the answer. I'm like 2 minutes away.
Okay.
Yeah. No, I got this. I'm cooking something. I just can't get this stupid syntax to work the way I want it to.
Oh, I don't know what you're trying to do there. What's the 2 hashtag?
Convert it to binary.
Oh.
Using this new syntax too.
It's so funny. I was talking about how I wanted to do this way of doing it, but then I decided not to.
Dude, it's really, really good actually. Oh, I see what the problem is.
I didn't think about doing it string wise. Because I was like, I'm gonna have to do a bunch of bitwise stuff to do that.
Yeah, that's what I'm doing.
Yeah, but you're doing bitwise stuff on a string?
No,
Oh, okay.
No, I'm doing it on the actual number. I'm converting the string that they're giving me to zeros and ones, and I'm converting that to a number. Then I'm just dealing with the numbers straight up. But
Gotcha.
I don't know what's wrong with this. I don't know why this isn't working.
You were afraid I still had to compare the length of attempts? No, because they come out sorted. Because my combinations function spits them out in order. So it'll give me all of the like length one ones first. And then yeah. The worst ones will be at the bottom. So as long as I break once I find one, we're good. We win. All right, what's this part 2? All of the machines are starting to come online. Now it's time to worry about the joltage requirements. Each machine needs to be configured to be exactly the specified joltage levels to function properly. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increase the joltage levels. We have a lever, okay? The machines each have a set of numeric counters tracking its joltage level. 1 counter per joltage requirement. So joltage requirements like 3, 5, 4, 7 mean that the machine has 4 counters, which are initially 0, and the goal is to simultaneously configure the first counter to be 3, the second counter to be 5, the third to be 4, and the fourth to be 7. Button wiring schematics are still relevant. In this new joltage configuration mode, each button now indicates which counter it affects. My technique is no longer useful. Oh no. The thing that I was like, oh, this is what makes it easy, that's gone. They got rid of that. You can push each button as many times as you like. However, your finger is getting sore from all the button pushing. So you'll need to determine the fewest total presses required to correctly configure each machine's joltage level counters. Well, I don't know how to do that. I can't do that. I don't know how to do this. I had one trick. My one trick has been used. It's gone. What the hell? That's not good. Uh, what, what, what do you mean? Okay. Okay. So we just gotta It's just a... I mean, if you think about it, it's just a big state machine, right? Oh, it's a really big state machine. How? Hmm. Maybe there's like a... Is there like a... Maybe there's like a greedy algorithm here. Because it increments the counters, right? Yeah. So maybe we can do like a greedy thing where... Well, is it gonna work though? It's not necessarily gonna work. Because a greedy thing would try to press the one with the most numbers until it can't anymore. But that doesn't necessarily work. How's it going, standard pointer? Hmm. This is my brain right now. This is the code in my brain. Mm-hmm. Hmm. Can you solve it for one button and then for two? True. I mean, we're still trying to find the minimum, right? Well, I don't know what you mean by solve it for one button. I'm lost in the sand. No, it's specifically one. Oh. I don't really know how that will help me. and ignore you. Okay. How are other people doing? The usual suspects are done. The rest of us, well, some people gave up yesterday. Nice. Crunching away on part 2. Yeah. I'm looking at part 2. I sure am looking at it. Oh, Brian, what happened? He fell off. He's cooked. So, yeah, because we know we can't go over. But the number of combinations just went up immensely. Maybe we can do the same thing. Maybe we can go through the different combinations of buttons, and we can eliminate some right away, right? If we don't have any buttons that like can increment a specific counter that we need, we know that can be eliminated. Does that even help though that much? Because most of them are gonna have that only trims like the very beginning of the tree. Okay, how else can we trim? Yeah, and the going through them in order doesn't necessarily get us the smallest one, right? Because like we might have a solution that works with 2 buttons, but it doesn't give us the smallest answer. Fuck. This one is hard. Okay, this is interesting. This is something. Whatever the biggest number in the set is the lower bound on how many button presses there will be. Right? If there's a 12 in here, we have pressed at least 12 buttons. That's interesting. Do an upper bound? I guess the sum of them would be the upper bound. We've pressed 12 buttons, but we haven't pressed 14, 21, 33, 34 would be an impossible number. So somewhere between 12 and 33. So we just have to try every permutation of 12 and 33 button presses. Simple. But what does that look like on our input? Let's give that a shot. What's solution 2? 33. Okay, everything up until this, replace it with this. Hey, thank you for the raid. How was your stream? What were you up to? You forgot your raid message? What have I done here? This? Okay. Stream went mostly well. As opposed to all well. I see. Found some interesting CSS stuff I didn't really know about. That's fun. Why didn't that work? How goes the bashing? Part 1 was good, but part 2 is kind of crazy. Kind of a lot. So if I want to find the maximum of those, let's make a function called do the math. While read array, can we do echo the length of the array just to see? So that should be like 4, 5, 6. Yeah, cool. So I want to loop through this array. Do done. Max equals 0. L equals array I. If L greater than max, then max equals L. And then total equals 0. Total plus equals L. Echo max total. All right. So those are our ranges. Total minus max. And then you can sort those, see how bad it gets. File equals input.txt. All right, 1451. That's a big number. Is that yeah. 1451. Cause what is that? 13 pick 1700? Let's see. 13 pick 1700. It doesn't even do the math. No. NPR calculator. No, chooses is different. 13 pick. Oh, N has to be bigger. Oh wait, is this with replacement or without? Both need N to be bigger? What am I trying to calculate? I guess you could do no. I don't know. Yeah. It's like how many ways are there to distribute this many numbers into this many buckets? And the answer is a big number, I'm pretty sure. How to count possible distributions. Meh. Meh. I don't care. It's a big number. Yeah, this is fucked. This is the type of programming problem that like if somebody at work was like, "Yeah, you have to solve this." I'd be like, "We can't. Can't be done. We can't be solving that." Like, you know how many like how much that's going to increase our compute cost? We can't just solve that. Our whole website's written in Bash. Like, how are we? Can't do that. $13, huh? 13. I don't even know how to do it for the sample. I have a vague memory of something I want to try. I can't remember how to do it. Yeah, I don't even have that vague memory. Offload it to the client. Yeah, edge compute. Well, at least we don't need the lights anymore. We can get rid of that. Here, let's start with that, you know? Let's keep this around and then just cat our file side. Do I want to send? I don't know. Yeah, sure. We can set that. No, we can cut it away. Cut D space F2 onwards. There you go. It's gone. Get it out of here. Then we can go into the swoop, and then swoop can say while read dash a stuff do done echo stuff. I want to move the first one to the beginning. Let's just swap them. Len.
Dude, that was way worse than I thought.
You got it?
No, I didn't.
Oh.
I still have a solution running and my CPUs are maxed out, so I don't think I'm doing this right.
What? All right,
Yeah,
hold on.
dude.
Part 2 is we might just need to team up. I don't even know. It's not good.
Oh no. I still can't even get part 1. I'm trying to, I don't know. I'm brute forcing it basically, and there's 9 that are being really tricky. 9 of them are being
probably the 13s and the 12s.
That's what I'm thinking, yeah. I don't have any logs, so I can't actually see, but you know, the CPUs are unhappy.
Jeff, everyone has an idea for part 2, but is giving up for the night. Damn.
Oh man, it's really that bad. Oh god.
I don't even know. Stuff. 1 minus 1. 1 minus 1. Temp. There we go. I made a function called swoop that swoops it. Swoops it around. We can get rid of all these stupid, unnecessary characters. You think I need little curly brace things, little parens? No, this is Bash. We don't need that shit.
I can tell you my answer is above 391. I don't know how much above it, but I can tell you it's above it.
Okay.
Yeah, I don't know how you figured this out. I'm parallelizing it and everything, and I am crunching the CPU.
There is a very relevant trick that does not work in part 2. So
oh,
or maybe
great.
there's a different version of this trick that I'm just not aware of for part 2,
Okay.
but you got it. What are you doing? Walk me through, because I'm not going anywhere.
I'm doing I turned everything into binary, so I just have, you know, the number I have and the number I want. So the button is just a binary number. The current button I have is a binary. Oh my god. My current number is binary, the buttons are binary. If I XOR them together, then it simulates a button press. So I have that going on. And then what I do is I just do breadth first search. That's literally all I do. I just loop over every possible button, press it, see if it's the answer. If it's not, I push that onto a queue and try again.
Okay.
Sounds like that is not what you did.
Well, that might be. I'm curious. I'm curious what yours looks like if you just print out like what buttons it's trying. Because it might not be that different from mine.
Okay. I mean, yeah, it's going real slow. So like there are still 18 outstanding things that are being processed out of the 177. So here, I will p-kill those. Now
No.
we... Wait, why are they still running? I don't know. Hold on. There we go. Now they're dead. Yeah, I could put some logging in there. And I could even what I'll do is I'll just lower the concurrency, so we'll just do one at a time.
Yeah, I mean, if you can just solve like number 1 from the sample, even
Yeah.
that would.
Cat example, head -1, pipe it into part 1.
Oh, that's
So,
fun. Head -1 in the sample. I like that.
yeah. So I didn't actually print anything, but I have a thing called what is it? I have a file that I put it to because I'm doing all the parallelizing things, so that's why this went to a different thing. So basically, you start at state 0, we try to press this, and this is our next state. Then we start at state 0, we press this, and this is our next state. And constantly we're just checking to see if it equals 0, 1, 1, 0, which is like the thing. We're constantly checking to see if it equals the thing that we're looking for. So the bottom line of input 0, 1, 1, 0, you can see matches after we had state 1, 0, 1, 0, and we pressed 1, 1, 0, 0.
Oh, interesting.
Yeah.
Okay, yeah, that's a lot different than mine.
Oh wow. Okay. Interesting. I don't even know how else you would solve this. But this solution is not fast. I will tell you that much.
I could try giving you the like helpful observation, and then I don't know if you can factor that into your code, but
No.
okay.
I don't want any hints. I already have some ideas that I have. Sorry, I've just been streaming too long. I'm mad tired. I'm gonna
Yeah,
start
you
caching
were
some results.
doing the. Oh, that might help.
Yeah. Yeah, I'm gonna start caching some things just so I can break out and not queue them if I've already seen them before. Yeah, my OBSs I've been streaming for 6.5 hours.
Yeah, I wonder if it's getting stuck in any cycles.
That's what I'm wondering too. I'm wondering if we're getting stuck in cycles, and on top of that, if I've already seen a number at a lower press count, then I should just give up. Yeah, I'll figure this out. I think I got this.
Yeah, I don't know part 2.
I want to get there so I can see it. Oh man.
It's
Oh man, I'm really excited.
I might have to just like I don't know. I don't think I'm gonna get it on my own. Like genuinely.
Really? Like
I
it's
I
really that bad?
I just don't have any idea. I have
Okay.
zero fucking clue.
Oh my god. Wow.
The numbers are they're big. All the numbers that I keep calculating of like how many tries I would need to do of a certain thing.
All right, I'm gonna try and get this. Give me like 5 minutes. I think I can do something.
Oh, you got it. You got it. Uh, any new solvers? No. No, nobody's doing it. Oh, Mark. No. Yep. Yep. A lot of people in this situation. Maybe someone else is live and I can ask them what they're thinking. Oh wait, Chi Chi's doing day 9?
And using intervals to find how big you can make the rectangle relative to each previously seen red point. Okay, take care, Neurosis. Shut
Oh, you
up,
can't see what
Zenko.
I'm.
Oh my god.
You can't
how
see
you
what
doing?
I'm chatting.
You need help with day 10? Okay. Fuck, do I have to do day 10? I'm like about to pass out too.
Am I looking for ideas? No, I'm just seeing what other people
I'm
are.
actually probably gonna
I
pass
have
out
like
after this.
genuinely no idea. But he's only on day 9.
You'd have to wait till tomorrow for day 10. Unfortunate, right? What are you gonna do about it? Fight me. IV
Dang.
pen STJ -1.
Done this wrong.
Is Alka doing it?
Save cache. Gets a result. It logs the solution. Adds it.
Ah, spoilers. Maybe. Vasher's still going? Yeah, that's how you know it's hard. Yeah. I mean, I would be open to some minor hints because I got nothing, and I'm just this is out of my pay grade. I came up with one.
I got it.
You got it?
Got
How
it.
fast
Just had
does
to
it run?
cache. I do parallelization, so I don't know if it's totally a fair.
Yeah,
Thing.
even with the parallelization, how long?
At 0.25 seconds.
Oh, okay, shit, fuck. Mine's 5 seconds.
Oh man, so what is this part 2? Oh, there's a lot of words here.
All right, hold on. Let me explain what you could have done for part 1.
Okay, yeah.
So scroll up to like the example,
Okay.
just so you have like something to.
Yeah.
Okay. So if you push that first button on the first row, what happens?
If I push the first button on the first row, I press 3, I toggle the third bit of the desired thing.
Yep. What happens if you push that button again?
Nothing. It's like a no-op. I've done nothing.
Yeah. So you're never going to push a button twice.
Yeah. Okay. Yeah. Good call. Good call.
Yeah.
Yeah. Okay. Good call.
Oh
man.
Now in part 2, you're going to push a button twice.
Oh God. Okay.
So maybe your solution is closer to the right answer than mine.
Let's see.
If it works for part 1.
So what do I have to do in part 2? I'll read it out. Do you want me to read it out loud while you're on stream?
Sure, I'm not doing anything.
Oh God, it's that bad. All right. Part 2. All the machines are starting to come online. Now it's time to worry about the joltage requirements. Each machine needs to be configured to exactly the specified joltage levels to function properly. Below the buttons on each machine is a big lever that you can use to switch the buttons from configuring the indicator lights to increasing the joltage levels. Ignore the indicator light diagram. Oh God. The machines each have a set of numeric counters tracking its joltage levels, 1 counter per joltage requirement. The counters are all initially set to 0. So the joltage requirements like 3, 5, 4, 7 mean that the machine has 4 counters which are initially 0, and that the goal is to simultaneously configure the first counter to be 3, the second counter to be 5, the third counter to be 4, and the fourth counter to be 7. The button wiring schematics are all still relevant. In the new joltage configuration mode, each button now indicates which counters it affects, where 0 means the first counter, 1 means the second counter, and so on. When you push a button, each listed counter is increased by 1. So a button wiring schematic like 1-3 means that each time you push the button, the second and fourth counters would increase by 1. If the current joltage levels were 0, 1, 2, 3, pushing them would change it to 0, 2, 2, 4. Okay, straightforward. You can push each button as many times as you like, however your finger is getting sore from all the button pushing, so you'll need to determine the fewest total presses required to correctly configure each machine's joltage levels to counters to match the specified joltage requirements. Consider again the example from bullet 4. Configuring the first machine counters requires a minimum of 10 button presses. One way to do this is by pressing 3 once, 1 3 3 times, 2 3 3 times, 1 2 once, and 0 1 once. Okay, so the fewest button presses required to correctly configure the joltage level, blah, 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 is 13. So we don't even care about the LED schematics anymore? We don't care about the
No.
first part of this? Wow, okay. So this is just a different problem now. Instead of trying to create a number, we're trying to get to a final state.
Yeah.
Okay. And have you looked at the real input? Like, there's some of those joltage levels get really high.
Yeah, they get pretty high.
Okay.
I did some math. So I came up with one observation so far. That's
Okay.
very maybe minorly helpful, which is just whatever the maximum number in the set is a lower bound of how many buttons you need to press.
Okay. Right. Yeah. Yeah.
And whatever
That's
the
true.
sum of all the numbers is the upper bound.
Yeah. Okay.
So
This
that's
is
a
useful.
range, but
Yeah.
I computed the ranges and it was like, oh, these are still pretty big
Yeah.
ranges.
Dude, because yeah, some of these, like I'm looking at this. This one has like so many different things, and this one goes up to 243. These are in the 200s, and there's like at least 10 numbers here. Oh, this is gonna be
That's
a
a lot of
nightmare.
buttons.
Yeah. Oh man.
Yeah.
Okay. I mean, yeah, I'm down to tackle this like together if you want to.
Yeah. I don't know how though.
Yeah. Because I'm also looking like you could technically go through like so I like your upper bound and your lower bound. Then we can go through each button and figure out like, okay, there's 10 buttons. Only 3 of them affect the 4th joltage meter. And the lowest one of those is like the
Yeah.
number 3. So we know we can only increment by 3. So it has to be like a multiple of 3. So we can do things like that, but I don't know if that like
I
gets
don't
us
even know how
anything.
to like put that into code though, of like
Yes,
having it
exactly.
narrow down the options.
And it does seem like there's a lot of 1s and 2s. Yeah, because each time you
At
push
least
the
they
button,
can't decrement. That's nice.
that's
That's
true.
helpful.
That's true. They're monotonic. Okay, yeah. So every time you push a button, it goes up by 1. Yeah. This sucks. This sucks, dude. Oh my god,
Yeah.
what the? Okay, let me think about this. Yeah, so you do have an upper bound and a lower bound, but they're huge.
I guess yeah, what okay. If we sorted each button like make 4 or like however many slots you have, make that many buckets and then put
Okay.
each button that affects that column into that bucket.
Yeah.
What would that look like?
Yeah, because then we would know like we have, some smaller set of buttons that can only
Yeah,
affect that joltage level.
like I have to push these buttons this many times.
Yeah.
Some set of these buttons this many times. But what if it's just all of them? What if it's just all the buttons?
I mean, that's possible. Like that's completely possible. And that sucks.
Uh,
My God, I love pulling up your code. Stuff. Temp. Let's
Swoop.
go. Swoop.
So all Swoop does is it flips the last in the first column. I couldn't think of another way to do this.
Okay.
Because I
That's
want the
clever.
thing to be at the beginning and then all the buttons can be later. It's just
Yeah.
easier to think about. Oh, what did I just do? I had a TR here and it's gone now. Boop. All right. Buckets.
I'm gonna start my part 2 as well, but I'm not gonna have anything useful here.
Yeah. Yeah, this one's tricky. Maybe is there some useful thing in like Yeah, maybe you just go in order of how many buttons are in each bucket.
I'm just trying to get anything workable right now. Just to be able to print something to my screen.
Yeah.
It's such an interesting problem. Like, you literally just
It's cursed.
we have buttons, and when you click a button, they have array indexes in them, and all those array indexes get incremented. Like, that's like the core of this problem, and we just need to
Wait, say that
increment it
again?
officially. Like we have buttons, and each button has a set of array indices in them. And when you
Mhm.
click a button, we find the array indices and we increment them by one. Like that's the problem,
Yeah.
like distilled down
Until
to its
the
basic form.
until the array matches.
Yeah.
Uh maybe we just go BOGO algorithm. We just try random buttons.
Listen, I like that. I have a trick for some of these where I always like I try to think of every possible thing I can like throw at it. Like, does it make more sense to start at the finish state and try to work our way back to zero? But I
Mm,
think in this problem, it's the same.
no.
I think it's the
Yeah,
same.
it's the same.
It's yeah,
That
we're
does
decrementing, it's incrementing.
make the check easier maybe, but yeah.
Yeah, because then all the checks are the same. You just default the initial state and then treat every button like a decrement. It's basically the same, but I just try to do that with puzzles to try and like get myself out of the boxed in thinking because some of these are just so weird.
Yeah. There's so
I feel like we've done problems like this similar in the past. Like I remember the claw contraption one from last year. It was like a claw machine that goes some number in the X and some number in the Y, and you have to click it an optimal amount of times.
Did you finish last year? I didn't finish.
Oh yeah, I finished last year.
I think I got to like day 12 or something.
Well, get there this year and you'll be good.
Yeah. That's the goal. What do we got? 3 more? 2.5, really.
Yeah, not bad. Now I'm
Although
trying
if
to
you
think,
count
yeah.
part 2 as half the problem, like that's messed up. It's like 80% of the problem.
That's true. Yeah. God, part twos are always brutal. This one's interesting.
Yeah, it's something.
I kind of want to pull up that claw contraption one and see what I did. Is that cheating to look up
No,
past
no,
puzzles?
definitely not.
Of course, I won't remember which one it was. I just remember it was like I think it was literally called claw contraption. Oh my god, day 13 claw contraption. Because you said you think you did 12, I decided to start at 13. Wow. Incredible. Yeah, this was a fun one because part 2 was exactly the same as part 1, but it was like 10 trillion higher.
Yeah,
So,
classic.
yep. So day 13. Okay, I have code for that.
All right, I've managed to read the required state. So that's pretty
Okay.
cool.
Very nice. Look at that. Buckets and swoop.
Yeah, swoop is not really that necessary, but you can even get rid of this if you wanted to. Oh, that's just the comment that I got rid of. Don't know why I thought that would help.
Oh. In claw contraption, because you just didn't increment by 1, you incremented by like a random number. I ended up using greatest common divisor, GCD, to figure out if it was possible. But we don't
Is
need
that a
that here.
thing
We
here?
can get anywhere. I ended up cheating, I think. My GCD, my GCD, I wrote it in Python. Math.gcd.
There's no way this is a LCM problem, right?
It might be. I mean, if I remember correctly, I think you and I both suck at math, so.
No, I'm not don't suck at math.
Whoa, okay. Oh, I'm sorry. I apologize.
Just joining now, finish both parts? No, I think we're deciding to team up for part 2 because holy shit. All right, so here's the problem. I'll catch you up. We're at the factory, and we have input that looks like this. For part 1, you just kind of ignore this part. So what we really have is like, this is state of whether lights are on or off. So a period means it's off, and this means it's on. And then these are buttons. And each one of these buttons is wired up to flip whichever like indices that it says. So like this one will only flip this one. And so for the first part, it starts with like all the lights start off, and you got to figure out what's the fewest number of buttons you press to make it look like this. And so that was sort of a head scratcher for a bit. But now in part 2, they're like, okay, now that the machine's on, that part doesn't matter anymore. It's this part that matters. And now when you press a button, it increments the counters in those positions. So 0, 1 means increment these two. Now you gotta find the fewest button presses that get you to here, which is different. Smells like a memoized problem? I don't know. The first part was, well, we did it different ways. You did memoization,
We did, yeah.
but I did hacks. I did combinations.
Oh, okay.
Which is what I thought you were doing when I looked over and you were doing binary stuff. I thought you were doing the
No.
fun, there's a fun trick where you can generate combinations of a set by using like looping from 0 to 2 to the n minus 1.
Okay.
And then looking at the bits to see which ones are in the set.
Oh. Nope. That didn't even cross my mind at all.
Anyways, I don't know how to do part 2. There's numbers that need to go up, and they need to go up a lot. And that's that.
No, that's right. That's exactly what it is. This is gonna be a tough one.
Do we start with the smallest one? Maybe we start with the smallest one and we figure out We try pressing some buttons. And then like whatever I do like your idea of decrementing them.
Yeah, I don't think it changes anything. It just makes it different,
Well,
like visually.
still going with
Like,
evil version of the change making problem. Yeah, it does feel like that. This one, I wonder if we were to sort out which buttons affect the first index, we'd get these two buttons. And so maybe we start by pressing this one 3 times. And that would give us a state where this is 0, this is 1. And so then we try here, and we just keep going until we hit like an invalid state, and then we like backtrack and stuff.
hmm.
I think that could work. No, because we want smallest though. And that changes things. That won't give us smallest. That'll just give us a solution.
That's true. Yeah. I mean, it's good, I guess, to get a solution.
But I want the smallest one.
Yeah.
Is this a Dijkstra's problem with a funny hat on? uh, yeah, anything that's greedy is not gonna give you the best solution, probably. It's gonna give you like a solution. I think. Well,
Trying to
so
think.
one idea I had was start by pressing like do a greedy algorithm where you press the button with the most numbers like as many times as you can, and
Oh,
then
okay.
continue that way.
Yeah, like do it until one of the numbers is at its target, kind of.
Yeah, basically, and then be like, okay,
Yeah.
what other buttons can I press now?
I haven't. I mean, I'm thinking the bucket idea makes sense. Like, go through all the possible buttons and say, like, oh, if you want to increment array spot 0, you need to press these buttons. So if you want that number to be 7 at the end, those 2 buttons will have to get pressed 7 times. Now, how they get pressed 7 times, I have no idea, but they have to.
Yeah, that's true.
Yeah, so finding out information like that might be useful. I'll work on that and see if I can get anything useful out of that.
I'll work on staring at it. No, yeah, I was
That might
headed down
help.
a similar path here with the
buckets.
buckets. Isn't this NP hard unless the problem specifically ensures there are some small buckets? I don't know. You think I remember what's NP hard or not? Changes all the time. That's not true. I know, it's a joke. Look at that. I made a little. If the puzzle was to make that, I made it. If the puzzle was to do this, I'm good.
Your stream's a mess.
It's falling apart. Hmm. Okay. Let's sort some buttons. How hard could it be?
Impossible.
No, it's not impossible. Everything is possible. Now, this function needs to be called like make buckets. So I can have a variable called buckets. I can just do. Yeah. Uh, Wait, what am I doing? What are you writing?
Trying to come up with that algorithm I was talking about out loud. Trying to figure out like if we need to get a certain index. Like if we need to have 7 at the end of this, we need to figure out what buttons need to be pressed 7 times so we can start getting some like LCMs or something going. I don't know if that's the right thing to do, but that's what I'm thinking.
Mm-hmm. We sure don't have an easy way to check if an element is in an array.
No, we really don't. thinking that.
Contains equals 0.
That's really true.
That ain't right. All my buttons ended up in bucket 2.
Oh my god.
Oh. Why has that happened?
This is a tough one.
I see why. Aha. Okay, I bucketed.
Requires a minimum of 10 button presses? My god.
What do I do with my buckets? Make number soup? Hmm. I'm starting to think chat doesn't know how to do this problem. Except for Meep. Oh, we could merge the chat. Yeah, yeah.
Oh, that's true. Smart idea.
Well, boom.
Yo, what up, merge chat? Dude, I have no idea how to do this. I can get some cool information, but I don't know what to do with it.
Yeah.
Yeah, like if I'm looking at the first example, I know that in order to get the
Oh.
array index 3, which you need to click 7 times, you can only do that through button 0, 1, or 3. So you have to hit 0, 1, or 3 7 times. Some combination of that.
I made buckets. It's interesting for the third example. There's only one way to increment the 5th column, which is the big button that does everything.
Oh, yeah. Yeah, you're right. Look at that.
I wonder if the inputs are like designed,
Wait, the 5th column?
or sorry, it's index 5.
Oh,
It's
okay.
the
Okay.
last one.
Yeah, yeah, yeah. Yeah, you're right. Oh, wow. Okay.
All right, let's look
Oh,
at
no.
these real buckets.
Dude, Sarf is lost. We're done.
Okay, so there's some that are like unsalvageable. This one, well, it's only 3. I kind of want to print out who has the fewest buckets for each one and see if they all have like one button that kind of drives it. This one has 2. This one has 3. I haven't seen one bigger than 3 yet. 4. Holy shit, what is this test case? All the buttons do everything. Alright, there's at least one test case in there that is a monster. No, there's more than one.
I'm staring at my code waiting for like divine intervention.
Hmm. The number of lights per button doesn't matter. What? Only the number of buttons per light. Yeah, that's what I'm looking at. But there was one that had a lot. Here, let me print the length of these. Mm, uh, array keys, associative array. I always forget. It's the exclamation mark thingy.
Yeah.
Yeah.
Exclamation mark.
Buckets. Buckets. Um. I guess I don't care about the key. Oh shit, no, because I want to find the minimum of these.
Believe in you both. You've solved worse problems. It's very true.
Have we?
Oh, absolutely. I don't think this is an 8-hour problem. I might eat these words, but I don't think this is an 8-hour problem.
What am I doing? I think my brain is starting to be cooked.
Yeah. I think my brain is cooked. I think I might call it for tonight because we're at
Why didn't
almost the 8 hour mark.
why didn't that print
7.5 hours.
anything? Huh? That should have printed something.
Oh, all right.
Oh,
I'm going to
I
call it a
see.
night. So good luck on your endeavors tonight.
Thank you, thank you.
You're welcome. And thank you, everyone who has joined my stream and hung out with me all night. It's been a ton of fun. So go like, unsubscribe, and YouTube, Twitch, all that stuff, etc. Blah, 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 blah. Good luck, bad cop. And let me raid you before I actually sign off. Look at that. I remember this time.
Length is less than min. Can you not just make an array from a string like this? Maybe you gotta do it like this. No. Ugh.
All right. I'm jumping out of the call. See ya.
See
Bye.
ya.
Good luck.
Mm. No, it seems like it works. So then why? The length of all of these is 1? I don't understand. Like, it's not 1. I know it's not 1. Let me end this thing. It's definitely not 1. Why does it think it's 1? Whoa. Thank you for the raid, Dave Eddie. That was unexpected. How's everybody doing? Now that Dave's gone, I know how to solve this problem, and we're going to actually just do it real quick because I was just doing a little trolling. I didn't want him to win the race. So we're just going to get it done real quick. Should be like 10 minutes. No problem. No, that's a lie. His channel is called You Suck at Programming. My channel is called I Suck at Programming. And this is where you just watch me struggle for however long until I give up. What the fuck is going on? What the fuck? What the fuck is this? Why is this not working? You know what I mean? You ever wonder this? Can we echo what I is in this case? 0. I is 0 every time. Something is suspicious. Can we change this to like key maybe? What? What? All right. Good luck at work. Wait a minute. Wait a minute. No. Stop waiting a minute. Oh, what am I do? I think I'm almost done because I just realized what I was doing. I thought this was an associative array and it's not. It's just a regular array. What am I doing? For I less than the length of the buckets, do that. Why are you still betraying me? Because I said that. Length. It's still not right. Like, hello? Oh, what? What the? Dave, I broke Vardump. What? Your program broke. What happened? Is it supposed to do that? That looks not right. Oh, is it because I'm sorting it? Okay, hold on. Okay, that was my bad. Why does my array just this? That's not what I want. I want this. Okay. All right, we're getting somewhere. But also, if I have a break here, why is it running so many times? Oh, because I'm... Okay. Wait. Yeah. Okay. All right. It's working now. Leave me alone. 6. What did you say? If it's above 4, we're cooked? It's 6. It goes to 6. Only a couple of times. 2 5s and 2 6s. Why does it do that? It is 1 a lot of the times. 1 is nice. But it's only 1 at the beginning, and then it's not 1 anymore, right? You know what I mean? All right, hear me out. What if we... No, but it's sorry. It's yeah, that was gibberish. I wasn't talking about this. I was it's it's 1 at the beginning, meaning for one of these columns it's driven by a single button, but that doesn't necessarily mean like when you move to the next column, it's also going to be driven by a single button. So it might blow up in complexity later. Because we're only really looking for the minimum, so it's the first one. Just because a problem has a 1 doesn't mean it only has 1s, right? But it is a good start to have a 1. Because when you have a 1, you can just press that button. You know exactly how many times you need to press that button. And then you can eliminate that button from the universe. Which is nice. But yeah, how do we go about... You basically have to like go through all of the different distributing this number to its buttons. So like in this case, this has 3. You have to be like, how are we going to ration out this 7 to 3 different buttons? What are all the different ways we can give 7, split 7 to 3 ways? You can do 7, 0, 0. You can do 0, 7, 0. 0, 0, 7. That's James Bond. You could do 6, 1, 0. You could do 6, 0, 1. There's a lot of ways. There are a lot of ways. But okay, in the case of the 6, where are our 6s? Can we look at those? Can we label our data here? I mean, can I just print out the row after the min? What am I looking at this point? Row. Oh, it's an array. Okay. So for this case of the 6s, it looks like this. And all of our buttons are really tangled together. So we'd have to decide how many ways can I distribute wait, hold on. Do we know what index it is for? We have to put a second. Key. Sometimes I can type 2. All right, 0, 1, 2. How many ways can I distribute 55 things to 6 buttons? Isn't that going to be like a massive number? Does Google know how to solve this? How many ways can I distribute 55 burgers, 55 55 items into 6 buckets? This is a math formula I've seen before. Yeah, I don't know what the name of it is. Combinations with repetition? Is it? 5 million, if that's true, if the Google doesn't lie to me. It's a variant of the bin packing problem. That one. This one. This is what we're doing. Optimal solutions to very large instances of the problem can be produced with sophisticated algorithms. Weird algorithm. Weird algorithm 2. strongly NP complete. Unless P equals NP. So if we just prove that P equals NP, we can actually do it with a good approximation ratio. I think that's probably part of the problem, is proving that P equals NP. For any fixed number of bins, K, pseudo polynomial time. Any fixed bin capacity, B. Okay, okay. It's approximation. But is this actually right? Is this actually the math? How do you figure this is dynamic programming? I'm not saying it isn't, I just don't know what I would be. Caching. What is the name of this? Is there a name for this? Formula used as stars and bars? What is that? Is that a real thing? There's a link here. Where does this go? Identical objects into distinct bins. What? Oh. Oh. This actually would be a useful way to to generate them. I can reason about how to code that. You just move the bars around. Okay. Well, it would be slow, maybe, but maybe it's the input is designed that if you take the right path, it's not that slow. Because I assume it has to be. But the 55.6 thing being 5 million is not. It's not that well. That's 5 million to solve one column of one row. That's a lot, but they get smaller as they go. Like there's only 2 6s. This one's even bigger though. 0, 1, 2, 3, 6 by 63. Okay, it's only 7 million, maybe, if AI is smart. I don't know. Do we have a stars and bars calculator? Number of identical objects, 63. 6 groups. All right, this is a very different number to what Google just said. It's about double, a little less than double. 10 million. Whatever. Google was useful for getting us to the the name of the algorithm. Or maybe mathcalcs.org is wrong. I don't know. But with a name like mathcalcs.org, I kind of trust it. Note, for large values of n or k, the result can be a very large number. Okay. Could be Google in disguise. Oh no, they're a Google wrapper. Okay. I think this is going to take a while to write, and I don't even know if it's going to work, and I need to eat. So I'm going to stop here for now. I don't know. I don't know if I'm going to stream the rest of it if I try it. Like yesterday, I thought I was going to come back, but then I just kind of solved it offline. Yeah. I'm aware of what happened. Yeah. Yeah, it depends. But I do need to eat, and it is almost midnight. Yeah, math is too hard. You slept once? You have so much time to sleep though. Like you don't understand. Like you're spending like 30 minutes on part 1 and part 2. Come on. You could sleep whenever you want. It's not even time out of your day. I guess it probably took you a few hours of effort to get to that point, but we can't factor that in. That time's already spent. Yeah, sorry. Should have spent your time better. Why am I on? Sorry. All right, who do we raid? Should we raid someone stuck on the problem? I want to raid Meisaka. I don't know what she's doing. Always something fun. Please spoil me and whisper. Meep, are your solutions on the internet somewhere? Hi, no raid? Okay, I won't raid. Just for you, Athano, I'll keep going for 3 more hours. Does that sound good? Yep. Oh wait, the cancel button, it's not work. I can't. I'm clicking cancel, but it's not canceling. It's just, oh no.